Hi, we are back with the exercise 3. In this activity, we have to generate this pattern that is given to us, and it's a simple pattern, especially if you could generate it element by element, and it's not difficult to figure out that way. But we have been expressly told not to do it that way. So you might find that annoying, but often the real life challenges are somewhat like that. You cannot use the most obvious solution, and as annoying as it could be, you have to take it in the spirit of solving a puzzle and find out an alternative way of doing it. So to think about it, when you face a challenge like this, uh, where the mathematics itself is probably not that difficult, or you know the programming bits and pieces that you need to solve that problem, but putting it all together to solve the problem is the challenge. And how to do it when the solution does not appear obvious to you. So we would go through this process in this video to see how we can tackle that challenge. And one advice from me is that don't give up. You play with some things that you know, like some other functions, and see if that clarifies the problem at all to you. You can take a walk across the campus or even take a nap. After a good night's sleep, next morning the problem might seem easier, and often the solution is not obvious even for expert programmers. So you have to keep at it. That's the advice before we go into this short video. And it's done in step by step fashion. So we are going into giving you more hints. So you start with some hints, and if you feel that you understand what's going on and you want to try it yourself, feel free to stop the video at that point, and then like come back to it later if you need some more hints and solve it. Okay, let's take a look at it. All right, so let's start with the actual programming part. We see that we have these square pattern matrices of odd dimensions, and probably we all noted that if we look at the middle rows and middle columns, they have this sense of indexing, which is not from say 1 2 3, but it's the absolute values of -1 to +1. So instead of -1 0 +1, we have 1 0 1, and same is true for this one. And the middle columns have the same pattern. So this is a this is something that we probably like to utilize some point during the programming. Let's look at the hint. It requires us to, or well, it suggests that we multiply a n by 1 matrix of all ones with a 1 by n matrix filled with various values. And if we do that, so let's start with let's choose n equal to 3 for keeping it simple, and let's have matrix A of all ones, and it's a 3 by 1 matrix. And then the other matrix, we choose it randomly to set it as a 1 by 3 matrix. And if we multiply these two matrices together, what we have is this. So where we see that the matrix B, this row vector, it is repeated thrice, given by this column vector. So this is the good point to stop if you want to work on your own with this hint. Next, we are going to use the fact that we have already noted that the middle rows and the middle columns of these matrices, they instead of 1 2 3 here, they look like they're indexed differently, like from -1 to +1, while we consider just the absolute values. And the same is true for the for this bigger matrix. And we can try to recreate that. So why we're doing it that way is this. So you have seen when we multiplied this column vector, this column matrix with the row matrix, we generated this row thrice. And if we have the row matrix as if we have the middle row as what we require, then uh, it would be at least partially correct. So probably we'll be on the right track. So let's say we set as B um, the we have to index them differently. So instead of 1 to 3, we are going to do it from -1 to +1. So this is where we are going to utilize the floor function, because if we just have the n/2 to -n/2 to +n/2, then it would look like this, and this is not quite what we want. However, if we use the floor function here, we do see that it's close to what we want. And however, this is not quite we want yet, because we want it to start from -1 and not from -2. And we realize this happened because I put the negative sign here, but this would probably take care of it. Good. And we want just the absolute values, so let's set it this way. And now if we go back to this C equal to matrix A times matrix B, then we have reproduced the middle row. And this is probably another good point to stop and for you to think if you want to proceed from here on your own and try out certain different things. So finally, we are probably on our way to solve this puzzle. Although we see that here all the rows and columns, they're not very, they are all the same, all the rows, but they're not very symmetric. Whereas the matrices that we are supposed to produce, they're all symmetric. So one thing we might try to do, I mean, at this point, if the solution is not uh, jumping in front of you, then what do you do? Like you try different functions and you see if that helps you in figuring out the answer. So what happens if we try to take inverse of C? Does that take us anywhere? Oops. All right. Oh, so the matrix is singular to working precision. So that does not really help. Anyway, what happens if we take transpose of C? That kind of looks cool, because that might be helpful, because if you look at here we have this 101, and finally we have the 101 as the columns, and we have reproduced the middle row exactly like here. So maybe if we multiply C with D, is that going to take us anywhere? Nope, that doesn't help. Would it be the same if we multiply D and C? I mean, you know, matrix multiplication is not commutative, and woo, yeah, it's different, but it's not what we want. What about something simpler? What if we add C and D? Does that help? Ooh, this is what we wanted. So probably we should check this for a bigger number, n equal to 5, or maybe n equal to 7. So let's have n equal to 7, and then let's repeat the procedure. So let's choose a column vector which is n by 1. Oops. And then we have the row vector, which is the absolute values of uh, minus floor function of n over 2 to all the way to plus n over 2. And oops, okay, I see the mistake. Good. And now we have c equal to a times b, and then we take the transposition of c, and finally we multiply add c and d together, and this is exactly what we wanted. So you see, it's always not obvious how we are going to get to our answer, and sometimes the programming knowledge that is required is not that not that intense, but it's often a math puzzle or it's a science puzzle that we need to solve, and programming is a tool. So you you have to give yourself time, and you know, don't be harsh with yourself if that if that seems to be very difficult initially. uh, that's how we do these things. Hopefully this video was of some use. I'll see you later. Bye.